environment research project. Immediately after his submission of thesis in Pondicherry Central University, he was awarded with postdoctorate fellow by Department of Atomic Energy, Indira Gandhi Center for Atomic Research in 2013. To his credit, Dr.P.Thiyagarajan sir has published in 9 international journals, 8 international national conferences, and 16 presentation demonstrations in workshops. His research has been widely cited by researchers, and so far now he has got 74 citations with H index 5 and I-10 index 3. His research article was one among the 12 articles selected by Institute of Development and Research in Banking Technology for his first doctoral colloquium among 300 articles submitted throughout the world. Besides, he has also participated in various international national seminars, workshops, and faculty development programs. He is a regular resource person to deliver lecture in various colleges and universities such as Bharathidasan University, University Trichy, Alagappa University, Karaikudi, Sastra University, Tanjavur and Pondicherry Central University, Puducherry. I'm so happy to welcome you, sir. Thank you.
Thank you so much, Dr. Martin Sarnaino Prakash, for the nice introduction. It is always good to hear from the colleague. That's a nice introduction. Thank you. And good morning to participants. Whether my voice is audible?
Yes, audible, sir. Audible, sir.
Okay, okay. I'll just share my screen and then make sure that I will. Yes. So whether my screen is visible?
Yes, sir. It's coming, sir. Yeah. Yes,
okay.
Sir.
So thank you for this invitation and for this ATAL FDP on blockchain. So for the next 1 hour and so, I'm going to talk on consensus algorithm at the root of blockchain technology. So since I could not able to view the chat, if there is any questions, I will answer the questions at the end of the session. And Martin sir, if there's any interruption and if you want to increase my voice during the presentation at any time, please let me know so that I will do accordingly.
Yeah,
so,
sure, definitely.
So with that note, so we'll go through this agenda. So we're going to see introduction to blockchain. And before talking in detail about the blockchain, I thought if we talk only the blockchain, then it would be very core technical. So what I've taken is that I have taken the application of the blockchain in the current banking system, and what are the issues in the current banking system, how the Bitcoins overcomes the issues in the banking. And there is a myth, both the blockchains and the Bitcoins are the same, but it is not so. Blockchain is different, Bitcoin is different. I'm going to differentiate that, and I'm going to explain how this blockchain helps in the Bitcoin transaction and why we need this consensus algorithm, why the consensus algorithm is very important, especially for the blockchain. And there are many types of consensus algorithm. So more than 10. So I'm not going to discuss in detail, but the fundamentals algorithm like proof of work, proof of stake, and delicate proof of stake. I'm going to discuss those algorithms in detail. Finally, we'll have the Q&A. So what is blockchain? So from now, in the past 2 days, we might have got some background about the blockchain. So it will be a set of series of blocks, like the linked list. You know, a linked list will contain 2 parts. One is the information part, another is the address part. The address part will contain the address of the next node. So in that way, the linked list will be it will be like a linear data structure. So blockchain will also look like a linear data structure where we keep on appending the newly inbuilt transaction within the network. So it is believed that every 10 minutes a block will be created and it will be added to the blockchain after verification. So for now, we might have seen those preliminary discussions. So to start with, I have taken this C here. So this is a block, and each block is connected to the next block. I said in linked list will be connected with the address, whereas in the blockchain, you will have a hash algorithm. The first block will have hash of the second one. In that way, it will be linked. Each and every block will be linked, and we'll keep on appending the blocks with a new set of transactions so that it can grow linearly. So why blockchain is all about so hype, and why it has been talk of this century. So as I said, the blockchain application can be done in a variety of domain, and you see the Gartner it said that by 2023 the blockchain will support the global movement and tracking of 2 trillion of goods and services annually. So it has ventured even in the retail management, even in the logistic management, even in all walks of life, you can see the application of the blockchain. So it has been envisaged by this partner that around 2 million goods and services that blockchain will be supporting. So on the right hand side, you can see a figure which says that how the blockchain has been growing. So the average number of monthly initial coin offering, the ICO, which is under the blockchain, it is grown from 8 to 200. And Ethereum, which is a platform for implementing the blockchain, has grown 50 times larger. And the initial coin investment in the blockchain and Bitcoins, it increased 16 times. And 14 countries are already started exploring of developing official cryptocurrencies. So those are the signs and those are the indications that how this blockchain is playing its, spreading its importance in all walks of life. And around 2.1 billion global spending on the blockchain solution in 2018. And if you see in LinkedIn, the number of blockchains related LinkedIn job openings is tripled in the last year. This is also another sign that what is the need and what is the demand of the industry, because LinkedIn is one of the methodology by which people seek jobs. So the number of job openings, especially for the blockchain, it has been increased 3 times. So it is also indication that it is a need of the hour. And around $20 billion amount the global blockchain market is expected to be worth in 2024. It will be around $20 billion. And you can see the banks currently experimenting with the blockchain technology. So top banks have already started experimenting how we can use this blockchain technology. So 69% of the current banks are already investing on the research how we can do this banking in this blockchain technology. And 33% of the bankers is expecting commercial blockchain adaptation next year. And around 18 to 12 billion dollars reported a potential annual savings for the banks utilizing the blockchain technology. See, this is a very crucial point. So if you use the blockchain technology, the amount of savings that the bank is going to get is around 8 to 12 billion, which is very huge in size. If they adapt the banking technology, replacing the current traditional system, the amount that every bank will save is around 8 to 12 billion dollars. So these are some of the highlights and indications how the blockchain is growing leap and bounds. So if we look into what are the technologies that is behind this blockchain, we have blockchain program, we have peer-to-peer network, and we have this public key cryptography. So blockchain mainly uses this public key cryptography to secure the identities and the hash value to make the blockchain immutable. As I said, any transaction, any block which is added to the blockchain, you cannot change it. Immutable means it cannot change at any cost of time. And blockchain, as I said, is a distributed ledger. So where the peer-to-peer machines on the network help in maintaining the consistency and maintaining the distributed ledger. And the blockchain is nothing but a protocol, which is nothing but a set of programs that use strict rules how this blockchain should work. So you'll see in detail about all this technical jargon. So as I said, it is mainly relies on this public key cryptography. So you all know the public key cryptography. We have 2 different keys, private key and the public key. So the private key will be processed by the individual. It will not be known to the common users. Whereas the public key will be known to everyone who is involved in the transaction with that particular entity. So if you use this public and private key as a pair, so if you encrypt the data with the help of the private key, then you should use the public key of the user. For example, I'm going to send the data to B. Imagine that I'm A. I'm going to send the data to B. I want to send the data, then I always encrypt using the private key. And if I encrypt the data using the private key, the ciphertext will be decrypted only by the public key of mine. So it is like a pair, a reciprocal pair. So if you use one key for encryption, the reciprocal of the key, like if you use public key, you have to use private key for the decryption. If you use private key for encryption, you have to use public key for decryption. If you use public key for encryption, you have to use private key for decryption. So it's a pair key that you have to use in the alternate part. So this is what this blockchain uses as a main one, as a backbone. Second, again, it comes with respect to the public key. Since I said that blockchain, it's nothing but a distributed system where we'll use this peer-to-peer digital signature. So digital signature is nothing but any cryptography algorithm should satisfy the three properties: confidentiality, integrity, and authentication. And one more thing which is not to be satisfied is nothing but non-repetition. So non-repetition is nothing but a concept where a sender cannot deny that he has not sent a message. If I send a message to B, A has sent a message to B, later A should not deny that I have not sent the message. In such a way, the cryptographic algorithm should be designed. So for that, you see this again, the combination of this public key crypto systems has been used. For example, I'm having a data, and the first thing is I'm using the hash algorithm. Hash algorithm is a specific algorithm cryptography where if you give any different length of inputs, the output will be converted into a fixed length, and no two inputs will give a same hash value. These are some of the properties with respect to the hash algorithms. So I have a data, and I'm finding I'm passing the data to the hash algorithm. The hash algorithm will give a hash value. Then what I'm doing is that the signer will sign the data along with the hash with the help of his private key. So this is how the non-repetition works. So now I have a document, and the document is attached to the hash value, and put together the document and the hash value is encrypted using the private key. I said this public key is always working pair. So if I encrypt using the signer's private key, the same has to be decrypted only with help of public key of the signer. So once we sign this document, is called digital signature, and this document has been transmitted over the network. So now if you do the digital signature, and you can make sure that even if there is any modification or tamper in the document, it can be easily figured out. How we can figure out, that is what we're going to see here. Imagine that this document is being transmitted over the network, and it has reached the verifier, or the recipient has received it. So on receiving this document and the hash value at the receiver part, they will separate the document, and they will separate. Both are attached, right? So what they will do, they will separate this they will separate the document and this data, and they will separate the hash value. Again, what they will do, again, they will apply the same algorithm that is applied on the data, which will give a hash. And then again, what they will do, we have attached the hash. So again, for this, we will decrypt using the public key of the signer, and we will get the hash value. So if both these hashes are matching, then we can make sure that there is any change has been occurred during the transmission of the data from the sender to the receiver. If there's any change, we can conclude that the document is tampered, and we can say that this data has been forged. And this also ensures the non-repetition. How we can ensure this non-repetition? Because since the signer is using its private key, the private key, as I said, it is only known to the individuals. Individuals should not relieve the private key any other. So since it document both this data and the hash key is being encrypted using the private key, the later part, whenever the document has been received by the verifier, signer cannot deny, because they use the private key of them, so they cannot deny that they have not sent the document. This is again a background how this public key has been used extensively in the blockchain. So next important term which is involved in this blockchain is nothing but the peer-to-peer network, where the different entities are being placed across the network, and they are connected by they're connected. So imagine that suppose this is how the peer-to-peer network will look like. So imagine that A finds a transaction. Suppose A finds a transaction. Bobby pay 5 coins to Cindy. So this is Bobby, and A finds a transaction, and Bobby wants to pay $5 coins to Cindy. So what does it do now? Since A finds the transaction, now A will broadcast to the peers B and C in the network that this transaction will be taking place. So if the transaction is verified, then the peers here, the B and C, will forward the transaction to its peers. The transaction propagated rapidly across the network. So in broadcast, generally what will happen, if any information goes, it will go passes through all the entities, all the nodes which is there in the network. So this is, you can map with the distributed ledger. I will discuss that in later. So here this slide is main objective is that we introduce what is peer-to-peer network, where we a group of component systems are connected in the network, and any communication, it can be reached although all the nodes in the network. So I said this blockchain is all about distributed ledger. So I said, since it is distributed, we don't have any common central authority to have a ledger. So every nodes in this peer-to-peer will have their ledger, and there is no any centralized ledger. So I have given a cross mark. So see here, every Andy, Bobby, Kindy, and Dept, all of them will have their own individual ledger. And since it is a distributed computing, at any point of time, if you take a ledger from any of the person who is there in the network, the ledger value should be matching with all of them. In other words, the consistency has to be maintained in the ledger which is there in the distributed system. If there is no consistency in the distributed ledger, the entire blockchain system will fail. So arriving at the consistency is all about consensus algorithm. How we can make the consistency of the records in the blockchain is nothing but the consensus algorithm. See, if it is a centralized system making the correct record, if it is a centralized system having only one records and making consistency is not difficult. But in a distributed system, maintaining consistency is a very big challenging task. And this consensus algorithms help us to make the consistency in the distributed system. We're going to see how it is helping us to making the consistency in the distributed system. So this slide is mainly to make understand how this distributed ledger has been done in the peer-to-peer network. And if you see the ledger, it should be consistent. So Andy, $10 means throughout the peer-to-peer network, Andy should be only $10. There should not be any inconsistencies. Even $9, $8, no. Even a record, there should not be any inconsistency. If there is inconsistency, then this will not work out. We have to make sure that there is a consistency at any point of time the peer-to-peer network when you use the blockchain, especially for any of the applications. It has to be consistent. The record which is distributed across the blockchain should be consistent. So I said, yeah, block will be added to the blockchain only after a series of transactions will taken place. Only a threshold transaction take place. Those transactions will be added to the block, and that will be that new block will be added to the existing blocks. So if we look at the ledger, generally they have so many sample ledger where you can read Andes and the dollars. Generally, the account numbers will be encrypted, so a common man cannot able to understand what is the account number. And I have given you the balance on the right hand side. This is the ledger that will be available. So every transaction holds the details of transfer of currency from one account to the other. And here, see, I have mentioned the bank balance. So if I want to know bank balance of mine with respect to the blockchain, I cannot directly go to my account and I cannot calculate the balance. I cannot straight away refer the balance against my account number. So if you want to know my current balance in my account, I have to refer the series of blocks from the beginning till now. What are the transactions that have taken place? Then I can able to calculate only the balance. I cannot directly refer the balance. So this diagram help us to understand how this blockchain transactions will take place. So simply check, and now someone is requesting a transaction. So now the transaction is broadcasted to the peer-to-peer network. So once the transaction is broadcasted, then it will the network which is there, it will validate whether the transaction is authentic or whether the transaction can be done. Once verified, the transaction has become part of the new block for the ledger, and again that new block in which the new transaction contains, it will be now added to the existing block. Then we will be prompt to the user that the transaction is complete. This is how the blockchain, especially in the transaction, works. So as I said, that there is a myth that blockchain is nothing but a Bitcoin and Bitcoin is nothing but a blockchain. So it is not so. So if you want to clearly differentiate, blockchain is the technology that is used in the Bitcoin. So you can say the Bitcoin, the Bitcoin is being evolved only because of the blockchain technology. So the blockchain is the main one. And another, we can say that one of the application of this blockchain technology, we can say it as a cryptocurrency. So no, both are not the same, both are different. And blockchain is the technology that is used in the Bitcoin. So as I said, a blockchain is nothing but a distributed public database holding the encrypted ledgers. So what is a block? We can say a block is a current part of the blockchain. We record some or all of the recent transactions. So as I say, a block will not contain a single transaction. So the block will contain some of the transactions or all of the recent transactions. And once the transaction has been complete and it has been verified by the peer-to-peer network, that will be added to the existing blockchain. So every time a blocks get completed, a new block is generated. Every time we add a new block for the forthcoming transactions, we will have a new block that will be in process. So as I said, I will describe the importance of the blockchain, and I will explain how the consensus mechanism works with the help of this banking application. So, sorry for that. So to highlight the importance of this blockchain technology, we should know what are the issues with the current banking system. Unless otherwise we know the issue, we cannot really appreciate why the blockchain plays a very crucial role. So what are the issues with the current banking system? We'll see that. So one of the main issue in the current banking system is that the transaction fee. Imagine here that Chandler who wants to transfer money to Joe, $100. So obviously both are apart in two different places. So the only way of mechanism is that through bank they have to transfer. For the hard-earned money by the Chandler, he want to transfer to his friend Joy. He depends on the bank, and then he has to pay $2 as a commission fee to do the transaction. So for if you want to transfer 100, the 2 rupee will be taken as a transaction fee, and only 98 will reach you. So this is how the bank has been serving and providing service for the user. But don't you think that the bank, which is sitting as a middleman, which is between the sender and the receiver, is aiming, for one transaction it may earn $2. Imagine that in a per day how much hour of transaction take place, maybe 1,000 transaction take place approximately. So $2,000 will be paid as a commission to the bank. Don't you think that the hard-earned money by the Chandler, and he wants to transfer the money which is hard-earned by him to some other person of his wish, he has to pay 2 rupees, $2. So the transaction fee is really a big concern, and that is increasing actually. Now, even for ATM transaction, we can do only 5 in our bank, and our parent bank. If you do the transactions in another bank, then again they charge us. So of course we do pay for the ATM card, debit card we are paying for internet banking, annual service charge we are paying. Apart from that, for using the service more than the prescribed amount of limit which is prescribed by the bank, we are bound to charge by the bank. So this is one of the main issues, and now due to the ever-changing policies by the RBI, and the customers are really affected by that. So don't you think it's a big concern? It's our hard-earned money, and we want to transfer, and we have to pay as a commission of $2 when we want to transfer $100. Really, it's a big concern. So that is statistics which is given by the financial CNN money report, which says that way back in 2015, I'm not talking about the current scenario, 2015, JB Morgan, Bank of America, and Wells Fargo, they earned around $6 billion from ATM and overdraft fee in 2005. Imagine that. $6 billion they have earned since all the banks in US. They earned about $6 billion in 2015. Way back in 2015, the transaction of the current rate will be 30% less. In that time itself, they have earned around $6 billion only with respect to the transaction fee. So this is really high, and this is one of the really bothering concerns in the current banking system. Second issues with the current banking system with respect to the digital currency is nothing but a double spending. For example, imagine that Peter has only $500, and if he has the digital currency and he wants to transfer that 500 to Alice and Bob, at the same time, same instance, if we initiate the transaction of 400 to Bob and 500 to Alice, then especially this occurs in the digital currency, then banking transactions are always put to double spending. So if you look at here, the Peter has only $500, but if the transaction can be initiated cleverly by the Peter, then he can initiate this transaction on the digital currency. At the same time, same instances, if you want to transfer to 2 different parties, then he will transfer $900, but then his account balance is only 500. So the bank transactions are prone to the double spending, especially in terms of the digital currencies. The next issue with this current banking system is that the bank have been, that there are so many crashes and crashes with bankruptcy. So Martin said is an expert in the bankruptcy modeling. So that is also an issue with the current banking system. So these are the 3 bothering issues in the current banking system, and we'll see how this blockchain and the Bitcoin help us to overcome these current issues with the banking system. So now I said the Bitcoins is coming as a savior to save from all these issues with the current banking system. And I said behind the Bitcoin is nothing but the blockchain. So the Bitcoin is nothing but one of the applications of the blockchain. It is nothing but a cryptocurrency. It was launched, it is submitted as a white paper by Satoshi Nakamoto on the Halloween Day. Halloween Day in US is very famous. It is on 31st October 2008. This paper, a Bitcoin, a peer-to-peer electronic cash system, is a nice white paper you can download and read. It talks about the Bitcoins. Of course, this big background of Bitcoin is something about the blockchain. So this Satoshi Nakamoto created the reference implementation that began with genesis of 50 blocks of 50 coins. So immediately after he started publishing this, even before publishing this white paper, what is the cleverly is that he did register the domain bitcoin.org. Because once he published, then he have to register the domain name. It will be very difficult to get the domain name. So he registered way back in August. Then he published the white paper in October. So he registered the bitcoin.org in August 18, 2008. And on October 31st, he published this design about the Bitcoin. And in November 9, the Bitcoin project, which is developed by him, is registered at sourceforge.net. This sourceforge.net is an website where the open source project codes will be deposited. So he deposited the same on November. And if you see, after he done all these things, preliminary works in 2008, in 2009, the Genesis block was established at 18 hours, 15 minutes on January 3rd, 2009. So in 2009, January 9, the Bitcoin version 0.1 was released. And in January 12, first Bitcoin transaction has been taken place. These are some of the statistics when the Bitcoin started. So what is a Bitcoin? As I said, a protocol that supports a decentralized, pseudonymous peer-to-peer digital currency. So it's actually Bitcoin is nothing but a protocol. Protocol means nothing but a set of rules that support decentralized. So for now, we have seen we always comfortable with the centralized system. So what is the centralized system? We have RBI. So all the banks are connected to the RBI. So any transaction, for example, if I have an account in IOB, any transaction which I make here, then it will be updated in the main branch of IOB, central branch of IOB, then it will be updated. So we always rely and so far now we have been doing the transaction only on the centralized system. But this Bitcoin and the blockchain is nothing but decentralized system. We don't have any central authority. So all the parties are who is involved in the transaction will hold the ledger. So we don't have any centralized person who will take care of that. Then many problems with the centralized system. Then only such as that main problem is that if there are any things happen in the central mechanism, then the whole system will not do anything. So only we move to the distributed system. So this protocol that's Bitcoin, which is nothing but decentralized. It's a pseudo-anonymous peer-to-peer digital currency. So the Bitcoin is nothing but a publicly disclosed linked ledger of transactions stored in the blockchain. So we'll see about this in detail. So Bitcoin is the first decentralized digital currency that came into existence way back in 2009. Then after that, we have so many coins. Till now, we have so many coins. But this is the first digital currency you can say came into existence. As I said, that this Bitcoin uses cryptography to control its creation and management. And so we cannot create any number of Bitcoins. There is a number of restrictions by which you can work on the Bitcoins. So it has been envious that the cryptography and mathematical envious that Bitcoin will be exhausted by 2140 years. It will be exhausted. So as I said, the Bitcoin is created and held electronically in a peer-to-peer open ledger called the blockchain. And what is a ledger? A ledger is nothing but a series of blocks. A blockchain is produced by using a software that solves a mathematical problem. We'll discuss this in detail. So now, before that, I'd like to play a video on the Bitcoin. Then we'll continue the discussion.
What is Bitcoin?
Martin said whether the audio is...
Yes, sir.
Okay.
Yes, sir.
Bitcoin is the first decentralized digital currency. Bitcoins are digital coins you can send through the internet. Compared to other alternatives, Bitcoins have a number of advantages. Bitcoins are transferred directly from person to person via the net, without going through a bank or clearinghouse. This means that the fees are much lower. You can use them in every country. Your account cannot be frozen, and there are no prerequisites or arbitrary limits. Let's look at how it works. Several currency exchanges exist where you can buy and sell Bitcoins for dollars, euros, and more. Your Bitcoins are kept in your digital wallet on your computer or mobile device. Sending Bitcoins is as simple as sending an email, and you can purchase anything with Bitcoin. The Bitcoin network is secured by individuals called miners. Miners are rewarded newly generated Bitcoins for verifying transactions. After transactions are verified, they are recorded in a transparent public ledger. Bitcoin opens up a whole new platform for innovation. The software is completely open source and anyone can review the code. Bitcoin is changing finance the same way the web changed publishing. When everyone has access to a global market, great ideas flourish. Bitcoins are a great way for businesses to minimize transaction fees. It doesn't cost anything to start accepting them, and it's easy to set up. There are no chargebacks, and you'll get additional business from the Bitcoin economy. For more information,
so that's a small video about the Bitcoin, which might have given you some idea. So now this slide is about, we have seen some of the issues with respect to the current banking system. We'll see how this issue which you've seen in the current banking system has been solved, or it is being addressed by this Bitcoin. So first issue we have seen is a centralized part. So the bank is always, it revolves around the centralized authority. And the second issue is nothing but the private ledgers. So private ledgers, before these banks are computerized, if you go to the banks, if you want to do any transactions, your account number will be there in the ledger. So they will segregate the account number in different ledgers, and they will check your account number falls in which range, and accordingly they will fetch the ledger, and they will do all the, if you have 10,000, if you want to withdraw 9,000, they will do that in the ledger by hand, in paper and pen, and they will, once you've done the transaction, they will close the ledger and keep it. That is how the banks has been working on before it is computerized. Even now it is all done in online, but then we have a private ledgers, and they are prone to attacks. All banking still, it can be prone to many of the attacks which is prevailing. And as I said, the digital currency in the current banking system can always be prone to double spending. So we'll see how Bitcoin addresses this problem. So Bitcoin address the centralized problem from moving to the decentralized part. Decentralized part means, I said, all the people who is involved in this Bitcoin transaction will be among the peer-to-peer network, and there is no any central authority which control the transaction. The transaction which is done in the blockchain will be monitored only by the peers, not by any centralized authority. So Bitcoins remove these private ledgers and make this ledger as a public in the sense those who involved in the transaction, everyone will have the ledger, and no more it is private ledgers. It will be shared. Every person who is involved in this blockchain network will have the ledger, and it is no more a private ledgers. And as I said, any transaction which is taking place in the blockchain and any block which is added in the blockchain, it is very highly impossible to change the transaction which is there in the blockchain. So if a set of transaction which is added to the blockchain, it is appended to the existing blockchain, it cannot be muted. Muted means it cannot be changed. Whereas in traditional banking system, it always prone to attack. And the problem of double spending is there in the digital currency in the existing current banking system. It has been eradicated with the help of structure of the blockchain. So if in blockchain, if you see, you may ask whether there is any transaction fee in the blockchain. That in most of the blockchain there is no transaction fee, but slowly now they started introducing transaction fee, which is very, very, very bigger. So again, I want to emphasize the point that the blockchain is the technology behind the Bitcoins. Both are not the same. So we'll check how this transaction takes place in the Bitcoin. So imagine that we have the 7 group of people which is there in the network. So Kevin, Paul, Robert, Lisa, James, Stephen, Rahul. So now we have a scenario where the James wanted to transfer the 500 Bitcoins to Kevin. So if you look at this diagram, you can carefully note these all the people involved in this blockchain network, and each of the people have their own ledger. They have a document, right, that is called a ledger. So all the individual people should have the ledger, and now in this condition, we want to transfer the 500 Bitcoins. We have to transfer it to the Kevin. So that's what the agenda. So imagine that if you carefully note, there are some 2 people who have been designated as a miner. So Robert and Lisa have been designated as a miner. So whenever a transaction takes place, the transaction is a part of a new block that will be validated by the miners and Lisa. So whenever the transaction takes place, this transaction will be validated by the miners. Miners here among the peers, someone will be designated as a miner. So these miner will verify the transaction. They will validate the transaction that is transferring of money from James to Kevin. Once the miners verify the transaction, then this transaction, which is taken place from this James to Kevin of transfer of 500 bitcoins, will be approved. Then that will be transferred to all the peers so that they can update the records. Minus 500 bitcoins from Kevin and plus 500 minus 500 bitcoins from the James account and plus 500 bitcoins from the Kevin account. So the main job of miners is that to validate whether the transaction is perfect. So if you look at this, it will for confirming whether the transaction can take place in 10 minutes, but for verifying the transaction, it will take much time. So proportionately, for verifying whether the transaction from James to the Kevin is correct or not, to confirm the transaction is valid, it will take much time. But for completing the transaction, it will take only less time. So this is a pictorial representation of the blockchain. So with the help of the figures, can be able to frame a sentence with respect to the blockchain. So I've given you some figures. If you carefully note, I've given you some figures. Can you form a sentence with respect to the blockchain with the figures? Like you have to connect the figures and you have to frame a sentence. Connect all the figures which is given there. And can you frame a sentence? Can I give you some time so that you can come up with a sentence by connecting all these figures? The figures are placed in order. So if you guess the figure, you can frame a nice sentence with respect to the blockchain. So all the concept which is there in the figure has been discussed in the last 45 minutes. So please take a time. I will give you 2 minutes time. In the meantime, you can connect all these figures and you can come up with a nice statement with respect to the blockchain. Please. Participants?
Sir, good morning, sir.
Good morning.
Sir, can I tell this sentence, sir?
Yeah, please.
If you want to do calculations in a secure manner in the secure network using the database, no one is able to cracking that content. Is it correct? I don't know, sir.
Rani madam, that's a good guess. I appreciate that. Many of the terms you framed it correctly, but the last portion, some of the main components are missing. I appreciate your effort. Thank you, ma'am.
Thank you, sir.
So all these ingredients we discussed already. So you can, if you recall the discussion for the past 45 minutes, you can frame a nice sentence with respect to the blockchain. It is like a connect game which we have in TV. I'm sure I forgot it. So it's like a connection game where they will give pictures and you want to connect the pictures with the Tamil song. So given a picture with respect to the blockchain, please connect it and you can frame a sentence. Any other, please, can you try? So take the first figure. Any guesses? Second one, what is it all about? Second figure. Second figure, we have all the arithmetic operations. Okay. Third one, what is it? Can anyone guess that? What is the third one? Third figure is all about.
Files, sir.
File. It's actually a ledger.
Okay.
And fourth figure is all about. What is the fourth figure talking about? Please unmute yourself and talk because you can able to view the chat box because I am in a full screen mode. If you want to answer, please unmute and talk. What is the fourth figure is all about? So someone said it's distributed. So it's nothing but we can say peer-to-peer. What is the fifth figure is all about? Fifth figure. Any guesses? What is it? Huh?
Bitcoins.
No, ma'am. Carefully go through the figure. What is the fifth figure is all about? Transaction, exactly. Fifth figure is transaction. Okay, what is the sixth one? You have seen these signals in traffic. What is it all about? In traffic, what does the signal means? Sixth figure. What does it mean?
Restrictions.
Restriction. So no way. Okay. Generally, we'll have no way. So it is cross. What is it? What's the seventh one? There's nothing but 3 dots are there. So we can say 3. What is this last one?
Transaction over.
No, last one I'm asking. What does the third one? Last one talks about.
Can't able to crack.
No. Actually, it's a party. So if you connect all these things, you can frame a nice sentence with respect to the blockchain. It's nothing but use of mathematics to create secure distributed ledger which enables transaction without the need of third parties. So the main objective why we need this blockchain, I have said, with respect to the banking scenario. Banking is nothing but third party. The communicating parties need a third party to do a transaction. There's a blockchain can do the secure transaction without the need of a third party. That is what the ultimate concept behind the blockchain. So the use of mathematics to create secure distributed ledger which enables transactions without the need of third person, without the need of third party. This is what the sentence that you can form, nice sentence you can form with respect to the figures which is there. So we now see about the blockchain. 2 minutes.
When you vote, have you ever wondered whether your ballot is actually counted? If you meet someone online, when you vote, have you ever wondered whether your ballot...
Whether the audio is clear? Can you able to hear it?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
Okay.
When you vote, have you ever wondered whether your ballot is actually counted? If you meet someone online, how do you know they're who they say they are? When you buy coffee that's labeled fair trade, what makes you so certain of its origin? To be sure, really sure, about any of those questions, you'd need a system where records could be stored, facts could be verified by anyone, and security is guaranteed. That way, no one could cheat the system by editing records, because everyone using the system would be watching. Systems like this are on the horizon, and the software that powers them is called a blockchain. Blockchains store information across a network of personal computers, making them not just decentralized, but distributed. This means no central company or person owns the system.
So now if we carefully go, this is a centralized system, the bank systems are centralized. And then the last we have the distributed systems. Okay.
Yet everyone can use it and help run it. System. This means no central company or person owns the system, yet everyone can use it and help run it. This is important because it means it's difficult for any one person to take down the network or corrupt it. The people who run the system use their computer to hold bundles of records submitted by others, known as blocks, in a chronological chain. The blockchain uses a form of math called cryptography to ensure that records can't be counterfeited or changed by anyone else. You've probably heard of the blockchain's first killer app, a form of digital cash called Bitcoin that you can send to anyone, even a complete stranger. Bitcoin is different from credit cards, PayPal, or other ways to send money because there isn't a bank or financial middleman involved. Instead, people from all over the world help move the digital money by validating others' Bitcoin transactions with their personal computers, earning a small fee in the process. Bitcoin uses the blockchain by tracking records of ownership over this digital cash, so only one person can be the owner at a time and the cash can't be spent twice, like counterfeit money in the physical world can. But Bitcoin is just the beginning for blockchains. In the future, blockchains that manage and verify online data could enable us to launch companies that are entirely run by algorithms, making self-driving cars safer, help us protect our online identities, and even track the billions of devices on the Internet of Things. These innovations will change our lives forever, and it's all just beginning. To learn more about the
So if you see this video, this has been illustrated why this Bitcoin is popular. As I said, in one of the components which this video is talking about is that the security which is given by the blockchain is it's much safer than the existing algorithms. So because of this immutable property, because of this distribution environment, because of the peer-to-peer network, because of the public ecosystem, it provides a strong secure mechanisms. If you see now the blockchain, as I said, it has been applied in all walks of human life, even medical records. I'm working on a PhD thesis on a medical record, how we can apply this blockchain on the medical record. So the application of the blockchain varies. One of the applications is but the bitcoins. So now come to the core of the presentation. What is a consensus algorithm? So why we need a consensus? As I said, when it is a centralized, you need not have a consensus because the central authority, whatever it says, that will be the final agreement. But when you have the distributed system, when so many parties are involved, imagine that you're doing work alone. So you are owner of that work, and whatever you dictate, that is the final one. The same work, when it is distributed among the common peoples, the work, if it has to be done properly, then everyone should coordinate to complete the work. Everyone should do the work to complete it. Because you will split the work accordingly, then there will be interdependability. So even if one of the part is not doing the work perfectly, the whole work will be incomplete. So whenever the work is distributed, you can analogous, you can map the distributed system. The work is distributed among the 4 faculties. All the 4 faculties should do the work with sincerity, with respect to the deadline. Then the work can be submitted on time. Even if one of them is lagging in their work, then we cannot able to achieve the completion of the work. So somewhere these faculties, as I said, as an example, have to arrive at a consensus to do the work on time and to share the work equally. So this is how the distributed systems also work. So the consensus algorithm was a decision-making process for a group where the individuals or the group construct and support the decisions that work best for the rest of the systems. In other words, you can call consensus algorithm as a form of resolutions where individual needs to support the majority decisions whether they like it or not. So whenever you involve so many people for any job, irrespective whether it is a Bitcoin transaction or for the blockchain or for any other common work, when so many people are involved, then there will be a coerce. And somewhere you have to arrive at a conclusion on the problem. And while arriving at a conclusion, we have to look for a majority decision. We cannot come up with a decision that satisfies with all the parties which is there in the peer-to-peer network. But the decision which is agreed by the majority of the people should be implemented for completing the problem. The same way the concession works. So the concession do not merely agree with the majority votes, but it also agrees to the one that benefits all of them. So it's always a win-win situation for the network. So as I said, blockchain is a distributed network. So we'll have a distributed ledger for all. So whenever there is a transaction, so the miners will verify the transactions. Once the miners is verified, that has to be validated. That has been agreed by all the peers. So somehow the transaction which is taking place, the new block is to be added, has to be agreed by all the people on the peer-to-peer network. So as I said, in a distributed environment, it is very difficult to arrive at a consensus. So this consensus algorithm facilitates to arrive at a common agreement when there is a distribution in the network. When there is a distribution among the work, especially here we have the consensus algorithm for the distributed network. So as I said, the objectives of the consensus model is nothing but coming to a common agreement, collaboration, cooperation, equal rights, participation, and activity. These are the main objectives of consensus model. Coming to an agreement. The mechanism gathers all the agreement from the group as much as it can. So the first is coming to an agreement. Second is collaboration. Everyone in the group aims to provide a better agreement that results in the group's interest as a whole. Third is cooperation. Every individual will work as a team and put their own interests aside. So they will not work only on the personal interest. They will work only with the interest of the team. Equal rights. So every participant in this peer-to-peer network, I'm just trying to map this with the peer-to-peer network. So every participant in the peer-to-peer network has the same value in voting. This means that every person's opinion is very important. Participation. Everyone inside the network need to be participate in voting. So no one will left out or no one can stay out without a vote. So when there is a disagreement, when there is a confusion, so everyone will give equal participation. Everyone's opinions will be asked. Last one is nothing but activity. So every member of the group should be equally active, and there should be no one with more responsibility in the group. So as I said, the work and the responsibility should be equally allocated among all the entities in the peer-to-peer group. These are some of the objectives that every concession model will make sure that it should meet up. So I'm trying to better explain this concession problem with respect to the Byzantine fault tolerance. So I will explain, then I will play a video about the Byzantine fault tolerance. This is an age-old problem in the distributed network. So the Byzantine fault tolerance is a system with a particular event of failure. So it is called as a Byzantine general problem. You can best experience this Byzantine problem in the distributed computing environment. So these components are distributed components are responsible for further conflicting information. So when there is a distributed system, if there is a conflict of information, then definitely that has to be discussed and solved among this distributed computer system. And if in the distributed system, if we not arrive at a consensus, what will happen? ultimately the work will not be done. Ultimately, the objective will be ruined. We will not able to achieve the target which is given for us. So, however, even if one of the component in the distributed system malfunctions, the whole system will break down. Imagine that, as I said, the work is distributed among the 4 faculties. Even if one of the faculty is not able to do the work, that's all, you cannot able to achieve the objective, because everyone assumes that everyone is doing the work and they will be concentrating on their part which has been assigned. And on the final day, when they come to consolidating all these things, when one of the component is missing, definitely it is not possible to complete the work. That's why in the distributed environment, even if one of the component in the system malfunctions, the whole system will break down. The malfunctioning component always causes inconsistency in the Byzantine fault tolerance, or I can say inconsistency in the distributed environment. And that is why it is not ideal to use the consensus system for the decentralized network. So we'll discuss in detail about this Byzantine fault tolerance using video. Better you can understand that using this nice video.
I'm going to explain it by using an ancient problem.
So please go through this Byzantine fault tolerance problem. It has been explained very nicely by this video. It's not a new problem, it's an age-old problem. I'm just trying to map this Byzantine fault tolerance problem which is prevailing in the distributed system to this blockchain, and how this consensus algorithm is helping us to overcome this problem.
I'm going to explain it by using an ancient problem that Bitcoin claims to have solved. It's called the Byzantine Generals Problem, and until now, it's been unsolvable. The problem goes like this. How do you make absolutely sure that multiple entities which are separated by distance are in absolute full agreement before an action is taken? In other words, how can individual parties find a way to guarantee full consensus? Here's the example. Imagine that you are a general in the Byzantine army and you're planning to attack an enemy city. You have the city surrounded by several battalions, each of them camped several miles from the other, and each of them led by another general. A coordinated attack on the city from all sides at the same time will be successful, but an uncoordinated attack will likely end in defeat. You have decided to attack at dawn, but you have no walkie-talkies or cell phones, and signals from flags, torches, or smoke could be seen by the enemy. How do you make sure with absolute certainty that all of the other generals reach consensus and all attack together at dawn? You could send messengers on horseback, but what if one of them is captured or killed before delivering the message? You would need to have a reply from each of your generals confirming that they have received your message, which means that they would have to send messengers to you on horseback, but what if they are captured or killed? What if a messenger is captured by the enemy and an imposter messenger with a fake reply is sent back to you?
I hope you understand the problem. Like the Major General is trying to attack a city from all the 4 ends. This attack would be successful only if all these sites has been attacked at the same time. Even if one of the militant entity is not attacking at the same time, then the attack will be defeated by the enemies. So somehow you have to make sure in the distributed system that all the 4 sides are attacked at the same time. How will you make sure that all the 4 sides are attacking the city at the same time? So you can always send a messenger, but then again, there will be a problem. What if you send a messenger and it has been captured by the enemy? What will happen? So these are some of the cases that has been discussed in the video.
They are captured or killed. What if a messenger is captured by the enemy and an imposter messenger with a fake reply is sent back to you? And how do the other generals know that the messages that they received from you are genuine and haven't been intercepted and altered by the enemy? Worse yet, what if some of the other generals are traitors and they send messages back to you confirming that they will attack at dawn when their true intention is to retreat? How can you ever be absolutely certain that all of your battalions will reach consensus and attack simultaneously? Like I said, this problem has remained unsolved for thousands of years, and at its core, it's all about individual parties being able to trust each other directly, no strings attached. Bitcoin claims to have conquered this problem. Now imagine that the battalions are actually computers on a network, and that the generals are copies of a computer program running a ledger. A ledger that, via some very complex math, records transactions and events in the exact order that they happened. The key here is that all of these ledgers are exactly the same for everyone. As soon as a change is made on one copy of a ledger, if it is proven to be true by the math, all other copies of the ledger are updated to match. What we have here is a distributed ledger that is also always in consensus. This is one of the first things to understand about Bitcoin. It is the first full consensus distributed ledger mankind has ever seen. This network can be expanded across the entire planet. It means that individual parties on opposite sides of the world can come to consensus on an event without requiring any third party as an intermediary for trust. Whether it's an order from a general to his troops or an order from you for a pizza, a distributed ledger confirms via math whether an event is true and records it permanently. Bitcoin, the first full consensus distributed ledger, is a trust machine.
So that video explains in detail about the percentage fault problem, fault tolerance problem, which is preventing the distributed environment. So we'll see how we overcome this percentage fault tolerance problem. And the video is explained how it has been done with the distributed ledger. It has been converted nicely. The army has been converted into the systems and the ledger. So why we need this consensus algorithm? So the main problem with the Byzantine is that to reach a common agreement among all the four armies to be attacking on the at the same time to the city. So even if a single fault occurs, the node will not come to an agreement or will have a higher difficulty value. So on the other hand, the consensus algorithm will not face really this problem. So the primary target is to reach a specific goal by any means. So we use a consensus algorithm which don't face the real problem which is illustrated in the video. We'll see that how we can arrive at a conclusion. So the blockchain consensus model are much more reliable and fault tolerant than the Byzantine problem which is discussed. So that is why when there could be a contradictory results in the distributed system, it is always better to use the consensus algorithm. So the conclusion is that whenever you have a distributed system, definitely we should have a consensus algorithm which will help us to arrive at a conclusion for the given problem. If you don't have any consensus algorithm which is being deployed, then the Byzantine fault problem will be prevailing and nowhere the network will come to a conclusion. So definitely we should have a consensus algorithm in place, or it will be deployed whenever there is a distributed system to arrive at a consensus. A consensus means agreement. When imagine that you have a distributed ledger. I will give you an example. Imagine that you have a distributed ledger. The four people are involved. At any point of time, if I ask what is the Thiyagarajan's balance from the ledger, they should be able to tell me the same balance. If A is telling I have $1,000 and B is telling I have $800, C is telling I have $900, and D is telling I have $2,000, then at no means we can do this Bitcoin transaction with respect to the distributed system. Because in any instances, you take any ledger from any party which is involved in the distributed system, they should give you only a single amount for any entity which is having an account in that blockchain. Okay, so you should not have different values for the different ledgers or the different ledgers from different person. So to arrive at this consensus, we should need the consensus algorithm. We don't have this consensus algorithm model happen. The same thing, how the Byzantine fault are suffering, the same problem will be occurring in the distributed system. So for that reason, we need the consensus algorithm in the distributed system. I hope I'm clear with the point. So the consensus algorithm is nothing but the soul of the blockchain technology. This method is quite simple, and those blockchains and consensus model are just a way to reach an agreement. So these consensus algorithms are a mechanism by which we can make a common agreement in the distributed system. However, there cannot be any decentralized system without common consensus algorithm. So it won't even matter whether the nodes trust each other or not. They will have to go by the certain principles and reach a collective agreement. So we will not bother about whether nodes or the parties which is there in the peer-to-peer or distributed network are having trust on among each other. Each and every consensus algorithm will have different mechanisms and nothing but a different set of principles. And that principles will be implemented to arrive at a conclusion in the distributed environment. So there are many consensus algorithms. Each consensus algorithm will have their own mechanisms or own principles to arrive at the consensus in the distributed environment. So there are, as I said, there are many consensus algorithms. So this is a nice graph I have taken from one or two blockchains. You can refer. and I cannot able to zoom it because it is cracking. I will list the algorithm. So we have proof of work consensus algorithm, proof of stake, delegated proof of stake, least proof of stake, proof of elapsed time, practical Byzantine fault tolerance, simplified Byzantine fault tolerance, delegated Byzantine fault tolerance, directed acyclic graph, proof of activity, proof of importance, proof of capacity, proof of burn, and proof of fate. There are many things. I've listed only the few. There are many consensus algorithms and there are many bitcoins, as I said, right? So each and every bitcoin uses different consensus algorithm. So now bitcoins by itself, it is using only the proof of work. So now we'll discuss what is the proof of work. So the proof of work is the first blockchain algorithm introduced in the blockchain network. So this is the first consensus algorithm introduced in the blockchain network. So many blockchain technology uses this blockchain consensus model to confirm all the transactions and produce relevant blocks in the network chain. So as I said, to arrive or to come to agreement, this consensus model are used, and this proof of work is the first consensus algorithm to be used to arrive at a conclusion for the transaction which is taking place in the blockchain. So the decentralized ledger system collects all the information related to the blocks. However, one need to take special care of all the transaction blocks. So what happened, as I said, I have already illustrated how a Bitcoin transaction takes place. I have illustrated with the 5 diagrams and 5 peoples. Among the peoples, there are 2 people who are designated as a miners. The same thing we have in the proof of work. The diagram is respect to the proof of work. So here in the proof of work, we will designate some people in the network as a miners. So the responsibility fall upon the individual nodes called miners, and the process they use to maintain is nothing but the mining. So what does the miners do whenever a transaction takes place? These miners will always mine it. Management will always try to verify whether the transaction is correct or not. So the centralized principle behind the proof of work, the main principle, as I said, every consensus algorithm will have a different principles. So the central principle behind the proof of work is nothing but to solve a complex mathematical problem and easily give out the solution. So what does it miners do? So whenever there is a transaction, whenever imagine that in the Bitcoin pair to distributed network, whenever there is a transaction, that transaction has to be validated. So among the people in the distributed network, we will designate some people as a miners. Who is miners? The miners are the people with the help of the computing power, they will be able to solve a mathematical problem. So what is the mathematical problem? The mathematical problem is very tough. We'll see what is the mathematical problem. So what is the mathematical problem that this miners will be able to solve? So I said the principle is that the miners should be able to solve the complex mathematical problem to give a solution. So what kind of mathematical problem will give for the miners? So this mathematical problem requires a lot of computing power to begin with. For example, you have a hash function. You have to find out the output without knowing the input. So you will not know what is the input, but you have to find the output. So another one is that integer factorization. Like you know how this public key crypto system works. When I giving a large number of around 256 bit, and you want to you convert that to integer, and you have to find the integer factorization. Again, that is a big cryptographic problem, and that is again a big mathematical problem. If the number is very large, then you will take many. You need many computing resources, and you need much number of hours to do the integer factorization. Or it may be a complex question in the mathematics. Those kind of puzzles will be given for the miners to solve. So why we need this kind of mathematical problem? Because as I said, to solve this mathematical problem, you need a lot of computing resources. So obviously, you know, any transaction in the internet is always now prone to distributed denial of service. You know what is denial of service, right? So denial of service is nothing but whenever the legitimate user want to use a service, the illegitimate or the attacker will make sure that the service is not available to the legitimate user. So when it is attacked from the different parts of the world, we'll call it as a distributed denial of service. So since this blockchain is the backbone of all the Bitcoins, definitely hackers will be more concentrated on the Bitcoins. See, among the website which is there, the hackers is only focusing on the banking websites. Why? Because that involves money. The same thing applicable for here also. Whenever you use blockchain for the Bitcoins, then now definitely the hackers will be having an eye to explore all possible ways to get into the Bitcoins and to get maximum benefit out of it. So in order to eradicate that, what does it have? We have miners. So these miners can able to solve a mathematical problem only with help of huge computing resources. So why we have this mathematical problem? As I said, if you want to solve a mathematical problem which is there in this consensus algorithm, in the proof of work, you need to have large computing resources. For that, you need investment. Okay, so definitely the hackers will not able to do such much investment to solve a mathematical problem which is given in the consensus algorithm, the proof of work. So this happens whenever the server feels like it has a DDoS attack, and to find out the consistent system requires a lot of calculation. Is under the assumption we keeping this mathematical problem such that it requires huge number of computing resources to solve a problem, and the hackers will not be able to afford to have this computing resources to solve a tough mathematical problem. So why the system has become so sensitive? So the blockchain consensus sequence relies mostly on accurate data and information. However, the speed of the system lacks tremendously. So one difficulty is that whenever the mathematical problem which you keep for the miners is too tough, the consequences will be that the miners will take so much of time to solve the mathematical problem. In turn, the block which is getting added to the blockchain will be very late. Maybe you can say 10 minutes we can add one block. So that is a much delayed time. So the real time it is much delayed. So we cannot able to afford if we keep too much of a toughness in the mathematical problem. So how is proof of work is implemented in the blockchain network? First of all, miners, as I said, miners will solve the puzzles, and after that the new blocks is created and confirm the transaction after it is there. So I will give you a good example for the mathematical puzzle. So you can always map this mathematical puzzles to the number lock. You know the number lock, right, which will be having in the suitcase. Imagine that it will be 3 digits. Imagine that you have a lock, you have a physical lock, number lock, which have some 10 digits. So this lock will be locked now with the help of the secret key, which is nothing but a number. I will lock this. So now I will give it to a person. This lock can be mapped to as a mathematical problem, which is there in the proof of work. So if I give a lock, number lock, which is having 10 digits to a person, what does it do? The ultimate objective of that person is to open the lock. The same thing here, the proof of work or the mathematical problem can be equally mapped to a number lock which having 10 digits. So the ultimate objective for the person is that to open the lock. So how will the person will open the lock? If you're giving a number lock with 10 digits, the objective is that to open the lock. So what are the ways we will do to open the lock? What are the only way is that you will do the brute force attack. So you will try all possible combinations of the 10-digit number. You start with 000. You will go on with 1, 2, 3, 4. Similarly, you will go for 10-digit number. A maximum 10-digit number you will go. So at any point of time, you will be succeeded. But only way is that you have to try all possible combinations for the 10-digit number. This much tough the mathematical problem will be. So to analogous, I can give you how tough the mathematical problem will be, like the number lock. So once you find out the solution for the number lock, it is easy to verify. That's why it will take much time to find the solution for this mathematical problem, but it should be easy to verify. The mathematical puzzle which is given for the miners, it should be in such a way that it should be tough to solve, but easy to verify. The same thing we can map with the number lock. It will be very tough to find a number which can unlock the lock. But to verify whether the number is correct is very easy. How you can verify? Simply get the number and you lock the lock again, and you will try to put the number which is given as a solution. And if the lock is unlocked, then you say it is a correct solution. The same concept has been used in the proof of work. The proof of work mathematical problem should be as tough to solve, but it should be easy to verify. Why it has to be verified? Imagine that there are 2 designated miners in the distributed network. The miners will solve the problem and they will say this is the solution. But that solution has to be verified. Who will verify the solution? All the other peers will verify the solution. How they will verify? They will give that the miners will give the solution, and the solution will be verified by the other peers. So it will be tough to solve, but easy to verify. It should not be tough to verify. It should be easy to verify. So once the verifier is verifying the miner solution, then only they will allow the miner to do the block addition to the existing blockchain. I hope I'm clear. This is what simple way I can illustrate how this proof of work works. So first of all, the miners will solve all the puzzles, and after that, the new blocks will be created and confirm transaction after that. So what exactly? What exactly is the proof of work consent algorithm used? As I said, the proof of work has been used by the bitcoins. So who use the bitcoins uses this proof of work, and it is introduced this type of consensus before any of the cryptocurrencies. So the blockchain consensus model allowed any kind of change in the complexity of the puzzle based on overall power of the network. So as I said, since this proof of work depends on the tough mathematical problem, it will take some time to. However, the miners will have a high system, even the world's highest computing power a miner can have, it will take some time to crack the mathematical problem which is given in the proof of work. So it will take some delay in creating a new blockchain because the toughness of the problem is involved in the proof of work. It will take around 10 minutes to create a block. That is considered as a slightly disadvantage with respect to proof of work. But this advantage is also an advantage that we can prevent the DDoS attack in this proof of work. That's why even though it takes 10 minutes to generate a block in the proof of work consensus algorithm, though there is a delay in generation of new block, this algorithm is still existing and it is competing with other algorithms or consensus algorithm only because of its toughness. So why proof of work why blockchain technology uses proof of work technology in the first place? As I said, it prevents the DDoS production. The main objective why, though there are disadvantages in using this proof of work algorithm, still it is being preferred because it prevents the DDoS attack. So as the main issue is that energy consumption. Imagine that you want to solve a mathematical problem, like as I said, and lock with 10 digits. You have to try all possible combinations. Of course, you can write a program to do that. Imagine that this is a simple mathematical problem. It is tough. I can give you to imagine, but reality, it will be too large. Imagine that how much of computing resources you need, how much of energy you consume to crack this problem. It's really unimaginable. So you need a greater energy consumption every time whenever the miner solves the mathematical problem. And this is considered as one of the main disadvantages of the proof of work. But this disadvantage also is an advantage for preventing the DDoS attack. So I would like to play a quick video which summarizes the main concept which I discussed on the proof of work.
What is proof of work? Originally dated back to 1993, the proof of work concept was developed to prevent denial of service attacks and other service abuse such as spam on a network, by requiring some work from the service user, usually meaning processing time by a computer. In 2009, Bitcoin introduced an innovative way of using proof of work as a consensus algorithm that is used to validate transactions and broadcast new blocks to the blockchain. It has then spread to become a widely used consensus algorithm in many cryptocurrencies. How does it work? In short, miners on a network will compete against each other in solving complex computational puzzles. These puzzles are difficult to solve.
See here, these are miners in the peer-to-peer system. Among the peers, some of them will designate as miners. So these miners, generally, they will have a high computing resources. Why they need high computing resources? To solve the mathematical problem. So there will be competition among the miners to solve the mathematical problem. So whoever comes up with the solution, they will declare this is the solution to all the peers which is connected to the distributed network. But that solution will be verified. Then those miners will be given advantage to verify the transaction. Then the miners who solve the problem will be able to add that block to the existing blockchain, and that miner will be rewarded for verifying the transaction because they spend so much of time, they spend so much of computing power to crack the mathematical problem. For that, as an token of appreciation, they will be rewarded with the blockchain. Initially, when the blockchain was at the primitive stage, the miners rewarding will be very high. But nowadays, you know, with the development of the blockchain, the miners rewarding is reduced drastically.
But very easy to verify the correct rules in solving complex cases. How does it work? In short, miners on a network will compete against each other in solving complex computational puzzles. These puzzles are difficult to solve, but very easy to verify the correct solution.
See here, they have mentioned it is very difficult to solve, but easy to verify. Okay, you have to design a mathematical problem. It is very tough to solve, but easy to verify. Verification should not take time. If the verification takes time, then again, for generation of a block, it will take an hours. So you have to design a mathematical problem in the proof of work such that it is easy to verify, but difficult to solve.
Once a miner has found a solution to a puzzle, they will be able to broadcast the block to the network, where all the other miners will then verify that the solution is correct. Let's take an example. Bitcoin is a blockchain-based system that is maintained by the collective work of decentralized nodes. Some of these nodes are known as miners and are responsible for adding new blocks into the blockchain. In order to do so, miners need to try and guess a pseudo-random number, aka nonce. This number, when combined with the data provided in the block and passed through a hash function, must produce a result that matches given conditions, for example, a hash starting with 4 zeros. When a matching result is found, the other nodes will verify the validity of the outcome, and the miner node is rewarded with a block reward. Therefore, it is impossible to add a new block into the main chain without first finding a valid nonce, which in turn generates the solution of a specific block, called block hash. Each validated block contains a block hash that represents the work done by the miner. This is why it's called proof of work. Proof of work helps to protect the network against numerous different attacks. A successful attack would require a lot of computational power and a lot of time to do the calculations, and therefore it would be inefficient since the incurred cost would be greater than the potential rewards for attacking the network. One issue with proof of work is that mining requires expensive computer hardware that consumes a large amount of power, and while the complicated algorithm calculations guarantee the security of the network, these calculations aren't able to be utilized beyond that. While proof of work may not be the most efficient solution, it is still one of the most popular methods of reaching consensus in blockchains. There are already alternative methods and approaches trying to solve the problem, but only time will tell what method will be the successor of proof of work. Stay tuned for more content.
I hope that video might have given you a good outline about what is proof of work and how it works. I will state in 2 lines. Proof of work nothing but we will designate among the peer-to-peers, we will designate some of them as miners, and the miners are them who will solve the mathematical problem. And those who solve the mathematical problem will start the solution to all the peers, and the miners will verify, the other miners will verify whether the proof is correct. If the proof is correct, the miners will be rewarded, and that miners who solve the problem will be authenticated to verify the transaction and add the block to the existing blockchain. So next, we have a different version of the proof of work called proof of stake. Again, this is a different consensus algorithm. It's the second top most frequently used consensus algorithm. So the proof of stake, again, it's a consensus algorithm that deals with main drawback of the proof of work algorithm. So we have, as I said, we have some drawbacks in the proof of work, so that has been addressed in the proof of stake. So in this one, every blocks get validated before the network adds another block to the blockchain page. This small twist. So what is the disadvantage we have is in the proof of work? Miners can join mining process using the coins at the stake. So what will happen here? So we will have miners in the proof of stake. We will have the miners being designated. So among the miners, we will give a chance. We will give a particular miners a chance only based on the bitcoins they have. So imagine there are 3 miners, and these miners have to bid to solve a problem. So like whichever miners will having a huge number of bitcoins. Suppose A miners have 30 and B is having 20 and C is having 10. So whichever is bidding more to solve a particular problem, those miners will be given an opportunity. In consensus algorithm, miners get previously chosen. So here, although the process is entirely random, still not every miners can participate in the staking. So all the miners of the network are randomly chosen. If you are specific, if you have a specific amount of points stored in your wallet, you'll be qualified to be a node on the network. So then the miners, you will choose the miners based on the bid which is giving to part of a network. Imagine the 3 miners and they want to be part of some peer-to-peer network where the transaction take place. So we'll allow the miners to be part of the network only if they have whichever miners having more number of bitcoins as a bid, they will give that miners as a chance to joining a part of a network. So after being a node, if you want to qualify for being a miner, you will need to deposit certain amount of coin, and after that there will be a voting system for choosing the validators. So it is all done. The miners will stake the minimum amount required for the special wallet stake. So the main simple how the difference is that here the miners will be always being part of the network only with the help of the coins which they are holding, or how much coin they are bidding to be part of the network. So whichever miners is bidding more, they will have a high probability. So that is called proof of stake. So I have a video for the proof of stake.
Hey there, my name is Xavier, and you might have read articles online saying that cryptocurrencies like Bitcoin uses... Hey there, my name is Xavier, and you might have read articles online saying that cryptocurrencies like Bitcoin uses enormous amounts of electricity to secure their networks. But why is that? And more importantly, what are the alternatives? Mining new coins takes a lot of computing power because of the proof of work algorithm. The idea was first introduced in 1993 to combat spam emails and was formally called proof of work in 1997. However, the technique went largely unused until Satoshi Nakamoto created Bitcoin in 2009. He realized that this mechanism could be used to reach consensus between many nodes on a network, and he used it as a way to secure the Bitcoin blockchain. However, the proof of work algorithm works by having all nodes solve a cryptographic puzzle. This puzzle is solved by miners.
See, in proof of work, we'll designate the people who are interested to be miners. Okay, imagine that out of 5 people, 3 people can be designated as miners. We will designate all of them as a miners. So all these three peoples will try to solve the tough mathematical problem. Imagine that all the three peoples will be equally competing, right? So they should have equal computation power. They should have equal electricity to solve the tough mathematical problem. So which is very, very time consuming, and it is waste of resources, because ultimately one will be solving the puzzle. So that has been addressed in the proof of stake.
And the first one to find the solution gets the minor. The proof of work algorithm works by having all nodes solve a cryptographic puzzle. This puzzle is solved by miners, and the first one to find the solution gets the minor reward. And this has led to a situation where people are building larger and larger mining farms like this one.
See, I said right, the miners will need a lot of computation power. So imagine this is the mining farm. Okay, it is there in Iceland. Imagine that how much of computing resources they have to mine it. So to solve the mathematical puzzle in the real world, to understand, I have given the number law. In general, the mathematical puzzle which is there in the proof of work, it's really complex, and you need this much huge. You have seen only a part of the screenshot here, part of the computing infrastructure. You need 10 times more than this infrastructure to solve the toughness of the mathematical problem which is there in the proof of work.
According to Digiconomist, Bitcoin miners alone are in a situation where people are building larger and larger mining farms like this one. According to Digiconomist, Bitcoin miners alone uses about 54 terawatt hours of electricity.
See here, this is the consumption of electricity used by the Bitcoin miners.
Enough to power 5 million households in the US, or even power the entire country of New Zealand or Hungary. But it doesn't stop there. Proof of work gives more rewards to people with better and more equipment. The higher your hash rate is, the higher the chance that you'll have to create the next block and thus receiving the mining reward. To increase chances even further, miners can come together in what's called mining pools. They combine their hashing power and distribute the rewards evenly across everyone in the pool. So, to sum it up, proof of work is causing miners to use massive amounts of electricity, and it encourages the use of mining pools, which makes the blockchain more centralized as opposed to decentralized.
So what happens? This video claims that proof of work makes the blockchain to be centralized. Why? As I said, to solve a mathematical problem in the proof of work, we need large amount of computing resources. I have shown you the screenshot also in this video. They've given how much of computing resources is there needed to solve a mathematical problem in the proof of work. So an individual cannot able to afford the infrastructure which is needed to solve the mathematical problem which is there in the proof of work. So what will happen? That kind of investment will not be given by any of the individuals. So what happens? So this group of miners, what they're trying to do, they try to gather together. So imagine that I have a huge computing power, and partner 2 has huge computing power, partner 3 has huge computing power. So these 3 miners will group together, and they will try to project as one miner, and they will solve the mathematical problem. So again, if we come to see here, this mining pools, we'll call them as a mining pools. These again will become a centralized one. So we come to the blockchain and the Bitcoins only to make from centralized to decentralized. But these miners, by clubbing themselves, they're making this problem again as a centralization. Again, this is against the core principle of the blockchain. So somehow we have to change it. That comes the proof of stake.
So to solve these issues, we have to find as opposed to pools, which makes the blockchain more centralized as opposed to decentralized. So to solve these issues, we have to find a new consensus algorithm that is as effective or better than proof of work. In 2011, a Bitcoin Talk forum user called Quantum Mechanic proposed a new technique that he called proof of stake. The basic idea is that letting everyone compete against each other with mining is just wasteful. So instead, proof of work uses an election process in which one node is randomly chosen to validate the next block. Oh yeah, small difference in terminology here. Proof of stake has no miners, but instead has validators. And it doesn't let people mine new blocks, but instead mint or forge new blocks.
Instead of miners and mining in the proof of work, in those terms will be called as validators, and the mining process will be called as minting or forging the proof of stake.
Validators aren't chosen completely randomly. To become a validator, a node has to deposit a certain amount of coins into the network as stake. You can think of this as a security deposit.
Like you have an advance, right? When we go for formula, you have some security deposit. Even for opening a lockers in the bank, you have a security deposit. Likewise, in the proof of stake, if someone is designated as a not miners, we have the term called here validators. So if someone is designated as a validators, they have to give some amount to the blockchain, like the amount that they have to deposit.
The size of the stake determines the chances of a validator to be chosen to forge the next block. It's a linear correlation. Let's say Bob deposits $100 into the network, while Alice deposits 1,000. Alice now has a 10 times higher chance of being chosen to forge the next.
See, like if randomly you choose 2 blocks, and among that Alice given $1,000 and Bob give $10 as a deposit, then the more times the chance that we choose Alice as the validator is high. So it's completely based on how much amount you bet.
Block. This might not seem fair because it favors the rich, but in reality, it's more fair compared to proof of work. With proof of work, rich people can enjoy the power of economies at scale. The price they pay for mining equipment and electricity doesn't go up in a linear fashion. Instead, the more they buy, the better prices they can get. But back to proof of stake. If a node is chosen to validate the next block, he'll check if all the transactions within it are indeed valid. And if everything checks out, the node signs off on the block and adds it to the blockchain. As a reward, the node receives the fees that are associated with the transactions inside this block. Okay, but how can we trust other validators on the network? Well, that's where the stake comes in. Validators will lose a part of their stake if they approve fraudulent transactions. As long as the stake is higher than what the validator gets from the transaction fees, we can trust them to correctly do their job. Because if not, they'll lose more money than they'll gain. It's a financial motivator and holds up as long as the stake is higher than the sum of all the transaction fees. If a node stops being a validator, his stake plus all the transaction fees that he got will be released after a certain period of time. Not straight away, because the network still needs to be able to punish you should they discover that some of your blocks were actually fraudulent. So the difference between proof of work and proof of stake are quite significant. Proof of stake doesn't let everyone mine for new blocks and therefore uses considerably less energy. It's also more decentralized. How is that? Well, in proof of work, we have something called mining pools. Those are people who are teaming up to increase their chances of mining a new block and thus collecting a reward. However, these pools now control large portions of the Bitcoin blockchain. They centralize the mining process, and that could be very dangerous. If the 3 biggest mining pools would merge together, they would have a majority in the network and could start approving fraudulent transactions. Another important advantage is that setting up a node for a proof of stake based blockchain is a lot less expensive compared to a proof of work based one. You don't need expensive mining equipment, and thus proof of stake encourages more people to set up a node, making the network more decentralized and also more secure. But even proof of stake isn't perfect, and it also has some flaws. Now you might think, hold on a minute, if I buy a majority stake in the network, I can effectively control it and approve fake transactions. And you would be correct. This is
like we have a disadvantage in the proof of work. It consumes lots of time and it needs lot of computing resources. It needs lot of power. We have the same. We have another disadvantage with respect to the proof of stake. What disadvantage we have? As I said, whenever whenever the validator is betting so much of money for doing this validating job, so that he will be designated as a validator to do the forging job. So imagine that a person is having more number of bitcoins than other. Then there will be monopoly. So every time the same person will be given to validate the things. So he will be monopoly, and he may tend to forge some of the transaction in the blockchain, which is there, which could not be done. That's a disadvantage with respect to the proof of stake.
Called the 51% attack, and it was first discussed as a weak point of the proof of work algorithm. If a single miner or group of miners can obtain 51% of the hashing power, they can effectively control the blockchain.
So what I say is, in the proof of stake, as I say, if an individual is gain more and more money with respect to the blockchain, since because he's having more money, since the proof of stake is always work with respect to the bid which is being submitted. So if the same person is gaining more money out of it, then we'll be having control over the blockchain, and the control may also lead to validate some of the forced transactions. So in generally the blockchain, if a person has 51% control, then you can control overall blockchain, like you have in stock market, right? So whoever having 51% of share, they will be designated as the chairman for the particular company. Similarly, in the blockchain, if 51% of the blocks are under control of a single individual, then they will be designated. They can control the entire blockchain and can do whatever they want in the blockchain, because more than 50% agreement is there, so they can do anything. So that will be the main problem with respect to this.
Proof of stake, on the other hand, makes this attack very impractical depending on the value of a cryptocurrency. If Bitcoin would be converted to proof of stake, acquiring 51% of all the coins would set you back a whopping $79 billion. So the 51% is actually less likely to happen with proof of stake. But that's not the only risk. Proof of stake algorithms also have to be careful how they select the next validator. It cannot be completely random because the size of the stake has to be factored in. But at the same time, the stake alone isn't enough because that will favor rich people who will get chosen more frequently, will collect more transaction fees, become even richer, and thus increase their chances of being chosen as a validator even further. There are a number of proposals to fix this, like coin age-based selection, for instance. Another potential problem is when the network chooses the next validator, but he doesn't turn up to do his job. This could easily be solved by choosing a large number of backup validators as a fallback. In short, proof of stake brings additional risks when compared to proof of work, and a lot of research is needed to understand these risks and then to mitigate them.
So again, proof of stake we discussed, and proof of work we discussed, and quickly I will give the compare this proof of work and the proof of stake. In proof of work, the probability of mining a block is determined how much computational work is done by the miner. As I said, the proof of work is heavily dependent on the computational resources. Whereas in proof of stake, it always depends on how much stake a person holds, how much coin a person holds. And in proof of work, a reward will be given to the first miner who solves the cryptographic puzzle. Whereas the validator does not receive the block reward. Instead, they collect network fee as their reward. So validator will not give directly rewarded. They will be collecting the reward in the form of a network fee. To add each block to the chain, the miners must compete to solve among the different puzzles. Here, in proof of work, we'll designate some 2 to 3 people as a miners. But these miners has to compete among themselves to solve the mathematical problem. Whoever comes first with the solution has to be verified by the other miners. They will compete here. But in proof of stake, if you see, there is no competition at all, because we will randomly choose one of them element as a validator who will try to work on the proof of stake. And next, in proof of work, as I said, there is a probability that the hacker would need to have 51% of computation power to add malicious block. If the amount of computing resources an individual hacker is owning above 51%, then he can add this malicious block inside the blockchain. And in proof of stake, hackers would need to own 51% of overall cryptocurrency. Here, 51% of computing resources is required, and in the proof of stake, 51% of the cryptocurrency is required to have that 51% attack. And the fifth point, if you see, in proof of work systems are less energy efficient. It means that they consume large amount of energy, and they are more costly. And in proof of stake are more cost and energy efficient compared to the proof of work. So in comparison, I'm telling this. And in proof of work, specialized equipment to optimize processing power. And whereas in proof of stake, we need standard server grade unit is more than enough. One server, single server is very much pretty enough to work with the proof of stake. We don't need any high funda systems to proof of stake. 7 point, initial investment is required in the proof of work because you need to have a large computing power. So it requires the initial investment. So here in proof of stake, initial investment to buy the stake and build reputation. So you need to invest much less compared to the proof of work, proof of stake. Compared to the proof of stake, you need very less investment compared to the proof of work. And some of the famous coins which implement the proof of work is nothing but Bitcoins use the proof of work, and some of the cryptocurrencies which use the proof of stake is nothing but UOS, Tezos, Cardano, Cosmos, Lisk, or use the proof of stake as a consensus algorithm. And as I said, you can apply this blockchain in variety of domains. I think that's a separate session by Professor Prasanna on application of the blockchain. So we can apply for banking. As I said, banking, how we can apply and how we can rectify some of the main issues which we have in the banking industry. You can apply for property governance, Internet of Things, food chains, healthcare, electronic voting. Even for the music industry, you can apply this blockchain. So that will eliminate the privacy. For example, I will take music industry. If we apply the blockchain in the music industry, the piracy will be eliminated. So these are some of the references, and in this presentation, I have used extensively the web resources and some of the papers which is listed, and like to acknowledge the same. And if you have any questions, I will be happy to answer. Any questions? Any questions?
No, sir.
Any questions from the participants?
Participants, if you have any queries, any doubts, any clarifications, you may raise or you can put your comments on the chat box.
As I said, there are many concession algorithms. I have discussed only the main two concession algorithms. And it will vary slightly, not too much, but then that very small variation is adding so much of advantage in the blockchain. You can always refer. There are many references given and many tutorials available. You can always refer. Any questions, you can please. Even I'm learning many of the concession algorithm. I'm not expert in concession algorithm. I have learned I have learned some 3-4 concession algorithm only. There are plenty. I have listed only few in the presentation. There are many concession algorithm available. Day to day, it is increasing. But if you understand the basics, then it will be easy for you to understand the rest of the concession algorithm. Any questions? And thanks, Dr. Maria Manuel Vinay ma'am, for that appreciation.
Thank you, sir.
Any questions?
So one question is raised in the chat box.
Yeah. Sir, please give some suggestions and advice for process with the career in blockchain. Career in the blockchain, so we have you have to take up a course, and you need not be. You can take up a course. No need to pay anything because there are plenty of courses is available in the Coursera, and there are plenty of resources is available in the internet. The only thing is that you need to have a very systematic approach to it. You have to understand the concept. Rather than my sincere advice to all people, irrespective of the blockchain, before venturing into some of the aspects, you should understand the fundamentals of it. In the due course of time, I felt that without knowing the fundamentals, people are directly venturing into the implementation. So implementation is not a big deal, actually. You know, wherever you go, even for machine learning, for blockchain, there are so many libraries available which you can import and you can do. But without knowing the fundamentals, without knowing the core mathematical concept behind it, there is no point in going for the implementation. So my suggestion for you, Suraj, is that to understand the concept, then you go for the implementation. Don't directly venture into the implementation. Either you can take up the course, a paid course, or make use of the freely available resources which is there in the internet. Because even for the coding, there are many open sources available. You can always refer. You can contact me in later stage. I will help you out. The main thing is that understand the concept, then you go for the implementation. Directly going the implementation is a very big hurdle where people mainly lacks in clarity of the concept. Thank you, Sivakumar sir, for the appreciation. Any other questions? Martin sir, over to you, please. I think there are no questions.
Yes, sir.
I thank participants for the patient listening. Thank you so much. And if you have any questions further in this, you can feel free to contact me. I will display my contact number over here. Thank you. I will give my contact number in the chat box. Thank you, sir.
Thank you, sir. Thank you, sir. Thank you for your contact number, sir. Thank you. So nice presentation. So you explained very well about the concepts. Not only concepts, you also given the examples, also played videos to better understand the concept, and you interacted well with the audience. Audience also interacted well. So thanks to everyone. Now I call upon Himansh to propose vote of thanks. Himansh?
Yes, sir.
Yeah.
Yes, sir. Thank you very much, Thiyagarajan, sir, for sharing wonderful knowledge and presentation on consensus algorithm. We believe that the insight knowledge that you have shared with us on issues with current banking system, Bitcoin transaction, importance of consensus algorithm, and the other algorithms, proof of work, proof of stake, and you have given a very good example within the videos we have learned a lot today, and it will help immensely in our career growth and research works. So it is really a very good learning on this 5 days FDP program. Thank you so much, sir.
Thank you, Dr. Martin sir and Himanshu, for the nice words, and thank you, participants, for your present listening. Thank you all. Thank you, sir. Thank you so much.
Thank you, sir. Thank you. Thank you very much for a wonderful presentation and valuable time you have spent with us. Thank you very much.
Thank you so much, sir. Thank you.
Thank you, sir.
Thank you, sir.
Announcement for participants, please be in the line. So you can take the next section starts by 11:30. So you are given a break, have a tea, coffee, relax yourself, then get ready for the next session. Thank you. Thank you very much.